Hello students, in this video we'll see the solution to the third problem on the quiz. In this problem we're given the joint PDF of two random variables x and y, and we're asked to find the conditional variance of x given that y is 1/2. So we first sketch our region where the PDF is supported. Here's our x-axis, here's our y-axis, and the line y equals 1 minus x looks like this. It starts with a y-intercept of 1 and slopes down with the slope of -1. And so x goes between 0 and 1, and y goes between 0 and this line. So our region of integration is this triangle. In particular, if we look at the value when y is equal to 1/2, so if y is 1/2, then we can see from the graph that the value of x goes between 0 and 1/2. So when y is 1/2, x goes between 0 and 1/2. And we'll need that in our problem. So to find this conditional variance, we need the conditional distribution function. We need f of x given y, of x given y. And in this problem, we know that y is equal to 1/2. So we have f of x given y, of x given 1/2. And what this is this will be the joint PDF, f of x comma 1/2, that's my value of y, over fy of 1/2. And so now we'll find fy of 1/2. So fy of 1/2, we'll find that by integrating out the x component of the joint PDF. So if I integrate the x component, well, when y is equal to 1/2, x goes between, so if we take this inequality, and if we can solve this for x, this says 0 is less than or equal to x is less than or equal to 1 minus y. And so in particular what this says that the x range when y is equal to 1/2 is 0 less than x less than 1/2. So I'll integrate from 0 to 1/2, and then I'll plug in my joint PDF. So I'll have a 2x plus 4 times y, but we know that y is 1/2 dx. So this will be an x squared plus, that will be a 2x from 0 to 1/2. And so now when we plug in 1/2, I get 1/4 plus 1, so that's 5/4. And so now we can update our conditional distribution. So we have fx given y for x 1/2 is going to be 2x plus, if I plug 1/2 in here, I get a 2, divided by 5/4, which we can write as 8x plus 8 over 5. And so now, to compute this variance, we need two things. So now we note that the variance of x given that y is equal to 1/2 is going to be equal to the integral from 0 to 1/2. That's my range of x. I'll have x squared times this PDF. That's the second moment. So this will be my first thing to integrate. That's my second moment. And then from the second moment, I have to subtract the first moment quantity squared. And so what we're using here is we're using the following fact. We're using the fact that the variance of x given that y is equal to y is the integral over your x limits of x squared fx given y x given y dx minus the integral over your x limits of x times fx y of x given y dx. And so if we compute these integrals over here, we see that the answer, when we plug it into the calculator, is 0.02055, and that is the solution to the problem. These are all polynomials, so they're easy to integrate, and then the most efficient thing to do is just to plug those numbers into the calculator and evaluate to get the final answer. Thank you very much.